Hello, parents. This is Mr. Allen, and I'm your son or daughter's calculus teacher, and I wanted to give you an update for the week of November 30th. This week we are studying the last new material that we're going to cover for this semester, and it is on optimization. So we kind of put all the pieces together of applications of derivatives in Chapter 3. So here's the problem. It says a solid is formed by adjoining two hemispheres to the ends of a right circular cylinder. The total volume of the solid is 14 centimeters cubed. Find the radius of the cylinder that produces the minimal surface area. So I found this image, which is the closest thing I could find to a cylinder with hemispheres on both ends of it. So this is the shape that we're looking at. So what we want to do is we want to come up with our primary and secondary equation. This is actually going to be the secondary equation, which is the volume equation, because we already know what the volume is. The volume in this case is 14, and it's just the volume formula for a sphere plus the volume of a cylinder. Our primary equation, we'll call it S, which stands for surface area in this case, is the surface area of this solid, which is simply the surface area of a sphere plus the lateral surface area of a cylinder. Now we can use our secondary equation, the volume equation, which we know is equal to 14, and we can solve that for R. So H would be equal to 14 divided by pi r squared minus 4/3 R. Now we can substitute that expression in for H in our primary equation for surface area, which will give us the following. With a little bit of simplification, S turns out to equal 4/3 pi r squared plus 28 over R. Now we can go ahead and do the calculus portion of this problem, which is to take the derivative of S, which gives us 8/3 pi r minus 28 over R squared. We want to set that equal to 0 to look for critical numbers, and there's only one value of R for which that's true, that's positive, and it's roughly 1.495 centimeters. When we find the second derivative of S and then plug in our critical number, we see that it is greater than 0. Therefore, we can conclude that this is going to be concave up, and we also therefore know that this value, 1.495 centimeters, is the radius that will produce the minimal surface area. Unfortunately, in order for this surface area to be minimized, you basically have to make the height of the cylinder 0. So some final thoughts for today. Number one, homework is still due on Friday. I'm trying to be very consistent about that, so this assignment will be due Friday night at 9 p.m. Also, we will have a test next week. In fact, it'll be on Monday, December the 7th. On Chapter 3, it will cover sections 3.1, 3.2, 3.3, and 3.4. I've already told the students about this. And I'd also like to note that I posted an announcement in Canvas for students to be aware that any missing work needs to be turned in by 9 p.m. on Friday, December the 11th for this semester. And of course, I'll leave with the Google Meet names that your son or daughter might need to join class. So thank you very much for your time and have a great day.